Hi, welcome to the session on finding, running, building, sharing, and deploying containers. My name is Scott McCarty, and I am a principal product manager with Red Hat. I'm going to cover a lot of material in this session, so I'm going to go through a couple slides to lay down the foundation of what we're going to do, and then I'm going to do a long demo where I demo a lot of different software. So let's start with a little foundation of how people get into containers. Often they start with something very simple. They start on a single node. They go out, they find some container images, they run them, and then they usually look once they've started to find something they like, and then run it a little bit. They're like, the next bright light goes off, and they go, you know, what would be really cool? What if I could add a little bit to this and then make it exactly what I want? And so often then they'll build on top of something they found. And then from there, they typically ask themselves, okay, well, what do I do here now, right? Like if I've built something locally, it's not really useful until I share it with somebody else. And so this is kind of an inner loop that you would see with any kind of software development, or really any kind of engineering at all, even if you're working on building a car. At the end of the day, you got to go, take some upstream supply chain parts, start to, get them to a state where you can run them, and then add some value, build something on top of it, and then share it. And then at this point, what happens? This set of variables here is kind of like what you would do with something like Docker, where you'd run it locally, or something like Podman, which is Red Hat's kind of alternative to Docker. And then you'd say to yourself, well, how do I run this in production, right? Like, what's the next step? How do I get this out into a CI/CD system to have this thing kick off and rebuild a bunch of times? I call that integrate. And then how do I think about deploying this in production, right? Like across a cluster. So I always say if you have two hosts or two containers, you need to start thinking about how you orchestrate the containers. And I call that deploy in this scenario. And to kind of show you kind of how Red Hat's portfolio maps that, and like what I'm going to show you here. We kind of look at Podman and Red Hat Enterprise Linux as kind of that fine run build. That's where you just start. If you're really, really new to containers and you're just getting your foot, dipping your toe in the water and just learning them, that's where you would go. You would use something called Podman build in Scopio. Typically, you would just use Podman. And then when you want to share it, you could build your own Quay server on premise, or we have something called Quay.io, which I'm going to demo. That's a hosted platform where it's a cloud, based platform where you can just push container images. And then I'm going to show you how to deploy it in Red Hat OpenShift, but running on a local node in an environment that would be really easy for you to set up yourself if you want to play with this. So with that, let me show you what the lab looks like. So this is kind of this is the workflow that we're going to flow through. So we're going to go out, we're going to look at Red Hat Container Catalog. We're going to show you what that offers you, and then pull something called Red Hat Universal Base Image, run it with Podman, basically go out, find some container images from the Red Hat Container Catalog, run them, build them with Podman, share them to Quay.io, and then we're going to basically integrate deploy on OpenShift on something called Code Ready Containers. Code Ready Containers is essentially a single node way of running OpenShift. Think of it as like a developer workstation kind of solution where you basically run a single command and you can deploy an entire OpenShift cluster. And this is a full-blown Kubernetes cluster running locally on my laptop, actually in a virtual machine. And you could set this up with literally one or two commands. So with that, let's jump into the demo. All right, you should be able to see my screen now. I'm going to start. I've scripted the demo, but I'm going to walk through it piece by piece. So the first thing we're going to do on this path from finding, running, building, sharing, and then deploying, we're going to start with a tool called Podman, and we're going to start with a base image called Red Hat Universal Base Image. I mentioned we're going to go out to the Red Hat Container Catalog. So registry.access.redhat.com is our registry. That's kind of the back-end OCI compliant container image registry that sits behind the Red Hat Container Catalog. And we can search that either in a web interface, or we can search it here by looking at from the command line. And so I'm going to show you the command line here. You see we went out and searched for the word UBI, and we got back all of these container images. Now, all of these container images are released under something called Red Hat Universal Base Image. It's essentially an end user license agreement that allows end users to go out and build upon these and distribute these however they want. But you'll notice there's tools like .NET, PHP, Golang, Python, Ruby, Node.js, Perl. It's a lot of what we would call cloud native languages. These are languages you would build modern applications in, and these are all freely redistributable. But the beauty of these is they're actually built with Red Hat Enterprise Linux container, bits. Essentially, the container images are built with these bits. And so when you run these container images anywhere, you can kind of think of them as like similar to a CentOS in that they're community supported, but they're enterprise quality. So when they're run on Red Hat Enterprise Linux or in OpenShift, they're fully supported, and you can certify applications on top of them. Now, these in particular, like I jokingly say, okay, that's fine. I go out, I kind of see Red Hat's publish these. Red Hat usually publishes pretty good quality, container images. I know they're known for producing pretty good quality stuff, but let me show you what that looks like, out here. So if we go to access.redhat.com/containers, let's go to this, and we'll show you what this container catalog looks like, from the web interface. You'll see here we get access to a catalog. We can see here, this is all the container images that Red Hat lists publicly that people can come and download. But let's search for UBI 8 real quick so we can see what this looks like from the other side. So you'll see there's a listing. It's almost like a product catalog. You'll go out here. Let's say I'm like, okay, like I mentioned, I kind of trust Red Hat, but I want to verify that I really trust Red Hat. Well, there are some things that Red Hat publishes to make this easier to digest, and we think these are pretty unique. Not really anyone else does this. We have something called the Container Health Index, and this is where we grade our own work. This is where we essentially communicate to our end users, hey, we rebuild these images often enough that there's not many CVEs in them, or not any if it's a grade A, but we can drop it to a B or a C if there's a few, low or moderate CVEs in it. We also sign these images. We also kind of show whether they need to run as privileged or whether they can run unprivileged, which is a really important feature when it comes to container images. We show you how to go out and get it, which is pretty normal at most places you'd go find that. But then I want to show you, if we go and look at all the tags, so you'll see something that's interesting about container images, and again, something that Red Hat does to try to prove. The newer they are, the better, because that means that they've been rebuilt. Like the last time we rebuilt our container images was 3 days ago, and that cleared out all these bugs and essentially, patched the container images for all these bugs and CVEs. But container images age like cheese, not like wine. They get moldy. The older they get, the worse they get. So you'll see, if you look from 7 months ago, if you're using a 7-month-old container image, it's probably a grade C or D. And so they get worse and worse. Now, that's kind of like our way to communicate to end users. Like, okay, not only are we a trusted brand for these things, but we also try to show you and be transparent with you the work that we're doing to make these things more secure. Okay, so I'm going to jump back to the demo. So let's say I'm an end user. I'm brand new to containers. I've went out. I've looked at the Red Hat container catalog. I've now convinced myself that I think these are secure. Okay, now I want to go, I want to actually run one of these. Okay, so now I've found something I like. Let's run it. Okay, you can see now I've just done a simple command with Podman. If you're familiar with the Docker command, you'll see that the interface is quite similar. But as I mentioned, this is kind of Red Hat's alternative to Docker. Podman run, same command line interface -IT, which means interactive terminal. I run this UBI 8 image that I found, and now I'm inside the container. So if I muck around in here, I can see, this looks like a Red Hat release. It's based on RHEL 8.1. Again, I mentioned it's called UBI 8, but it's really RHEL bits. So all the things that you know and love about RHEL, if you look at this looks just like a root file system from a RHEL image. Okay, so let's get out of here. Nothing too interesting in running an operating system by itself. Nobody typically wants to do that. It's really the workload that you care about. So like I mentioned, the next thing you want to do is typically build on top of this container image, right? So let's go here and let's do I've created a Docker file that has just some basic things to create kind of a core build. And then I'm going to build it, run this podman build -t. I'm going to tag it with this name so that eventually we can push this out and share it. So you'll see some pretty simple things here. We basically just installed a couple utilities. Often it's nice to have PS, often it's nice to have route, and often it's nice to have ping. So, these are kind of things that you might want in any of your container images. I'm kind of showing, like I said, to build a core build. This thing got committed locally, and now it is called it's got this name, but notice it's prefixed with Quay.io. So let's go look at that image. You'll see it's out here. It was built a few minutes ago. Technically, I built this a while ago, and then it just rebuilt it, so it didn't actually update it. So it's 33 minutes old. And then once we've built something locally, it's not very useful, like I mentioned, unless we share it with somebody. So what we're going to do here is we're going to show you how easy it is to push out to Quay.io. Again, I mentioned Quay is a hosted registry that Red Hat offers. It's free to use for end users, especially for open source users that just want to have a couple public registries or public repositories, I should say. And if you need private repositories, you can pay for those. But in a nutshell, I use this all the time. I just use the free account. So you'll see it pushed it out there. Once we've shared it out there, though, now this is where the demo gets more interesting. Up till here, it's been pretty basic. If you've used Docker or something like that, this should be pretty easy to understand. But now, how do we deploy these things in production, right? Like I mentioned, if you have two containers or two images, two containers or two hosts, that's where it starts to get more complex. You have to think about things like scalability, being able to scale out a web server to 10 copies. And then you also need to think about high availability. What if the container host dies? Like, I need to have enough. You have to start to think about the container hosts as capacity, right? And that's what Kubernetes and OpenShift give you, really. They give you that ability to orchestrate 2 containers or 100 containers. It's equally difficult. It doesn't matter. As soon as you get to 2, it's as easy as running 10,000 containers. And then as soon as you get to 2 hosts with Kubernetes, you now have high availability, right? So like, if you look at a regular OpenShift setup, it's typically about 7 nodes to make it truly like HA, so that it can have some worker nodes that can fail and any of the master nodes can fail. In this demo, I'm only going to show you a single node all in one, but I just want you to at least understand that the complexity it takes to get this to this one node all in one, I could go out and deploy this on a production Kubernetes as is, exactly like I have it here, and it would not incur any more complexity than what I just did here. You could essentially defer that complexity to somebody else to go run the OpenShift cluster. And to be honest, that's what OpenShift does, is it handles that complexity for you. That's what, especially OpenShift 4 and operators and all the things that come with OpenShift 4, which we have other sessions that go deeper into that. So how do we get, so the question though is, okay, so we've got some container images. How do we get from Podman to Kubernetes? Well, Podman has a really cool feature called Podman Generate Kube, and I'm going to show you how this works. So again, if you're new to containers, you're probably familiar with how to run a container like this. This is quite similar to the first command I showed you. So we're going to run a container. Okay, it's running. Let's go look at it. You'll see if we run a Podman PS, we can see the containers running. Here's the ID of the container. Here's the image. We ran bash. It's up for 2 seconds. But now, how do we get this running container? It's very easy to run a container locally, but then how do we get it into Kubernetes? We want to run it in the exact same way that we're running it here. Well, we can use this command called Podman Generate Kube. This essentially takes that Tron container that I ran, and we're going to export it into this YAML, and you're going to see what this looks like. So you see, it was a very simple command, ran very quickly, and now we're going to use Vim to just go look at this YAML. Kubernetes has been criticized for being complex. I argue it is not complex. It's the business problem that is hard. Running thousands of containers across thousands of nodes in production is just inherently complex. And that's a business problem that every enterprise has nowadays, because everyone is running microservices and web servers and essentially, thousands of services. And so that business problem in and of itself is complex. It requires being able to run those, that many containers or that many web services in production to basically compete in the marketplace. This is just cost of doing business today. So yes, the specifications in Kubernetes, essentially is the simplest way to do that. Now, that said, it's still more complex than running a single container on a single host with Podman. So you'll see this Kubernetes YAML is not super complex, but I wouldn't want to type this by hand. So I really like that Podman can export this. Then I can go out here. I can modify a few of these if I want to muck with these. I'm not going to for the point of this demo, but you see, having a starting template is a lot easier than just starting from scratch and having to type this in or go copy and paste, code from online, which the Kubernetes documentation is great, but it's still nice to start from a starting place. All right, so let's see, once we have this starting place, how do we submit this to Kubernetes to make it run? Well, let's go out and look at the Kubernetes environment that we have. So you can do this command called OC get nodes. This OC command, you can, in your mind, if you're not familiar with OpenShift, this is like OpenShift command, you can replace it in your mind with kubectl or kubectl. It's very, very similar to kubectl, but it has a few different verbs that you can run. You can do some things that you can't do with kubectl, and it's kind of our way of expanding and being able to handle the platform itself or manage the Kubernetes environment itself. We've extended it. But you'll see here, if you've ever used Kubernetes, this looks very similar. It's showing that this node, this is code-ready containers running locally on my laptop in a VM. Here, I'll show you real quick. If you look locally, it's running right here as a VM. And then you'll see it's the master and it's the worker. It's been up for 14 days. And then it's version 1.16 of Kubernetes essentially running. So now let's get projects locally and look. So you'll see OpenShift out of the box has a bunch of projects that it has locally. These are all for OpenShift to run itself. I don't want to deploy stuff inside of these projects. So I'm going to go out and create a new project called Tron. And then you'll see there's this beautiful command called OC new project. So it goes and does all the things I need to basically go into this project and run things. And then let's get the projects. You'll see again, now I have a new one called Tron. That's really nice. And now I've already been entered. Essentially, I'm now running my commands in the context of this project. So when I do this OC create, again, you can think of it as kubectl create. It's saying -file, and then it's going to go grab this YAML file that Podman created, and then I'm just going to run it locally. So now let's watch that get created. Now I'm watching the status. Basically, this OC get pods -w, it's a watch command. What it's doing is it's going out and pinging the Kubernetes API and basically just watching. And it's refreshing. You see like 2 seconds, at 2 seconds, 3 seconds, and then 5 seconds. Now it ran really quickly. So let's go on to the next thing and we'll see, okay, what does that look like? We'll use the describe command, subcommand. You can see, it started the Tron container. Well, it successfully assigned it to this node, which is a worker and a master, we know. Then it pulled the image from Quay.io, which again, I mentioned that's where we shared it from. So this went out on the internet, publicly pulled it down into that Kubernetes environment and it's running it. And then it started it. So you can see it's got, things like an IP address. Here's an, annotations that's running, the SEC info, so security context stuff. Essentially, it's kind of all the information about how it's running locally. This is almost like your, similar to your, Podman PS, some of that information that you'd see. So let's look. This is actually showing, okay, so now this Tron container is running. It's been out there for 67 seconds running out in OpenShift. So that was super easy, right? We ran one command in Podman, one command in Kubernetes, and we were able to run a container in Kubernetes without having to do anything. I didn't know how to write any YAML whatsoever, but it's probably not the most advanced use case. So let's try a little more complex use case. Often when you're building web apps, or even I've seen a lot of workload expansion in the last year or two in Kubernetes to where we're doing way more than just web workloads in both Podman and Kubernetes and OpenShift. Let's show running a couple containers in what's called a pod. So in Kubernetes, there's this concept of a pod. A pod is essentially one or more containers running side by side on a single host. And pods are useful because you can have like a web server and a MySQL database that get assigned together and talk through a socket, for example. Or you could have a TCP socket between two pieces of software, or you could even have like shared memory, things like that. When essentially containers are just processes, so you can run them locally. As long as you can assign them to the same node, you can do all the same Linux, Unix things that you would do to have these things communicate. So even if you're doing very complex things like video processing or handling, talking to, accelerator cards or doing all kinds of things, you can essentially control how these processes run. So what we're going to do is just do something very simple, but just to show you the complexity that you can handle. So we're going to do in Podman a pod create. So we're going to go out and create a pod locally. This is a different implementation in Golang code of a pod structure, but it is the exact same concept as what's in Kubernetes. So it is, again, one or more containers running within this construct called a pod. And then what we do here is we're going to assign, you'll see, we're going to actually assign a container. We're going to start it. It's called Flynn. We're going to start it in this pod recognizer. And then you'll see when we run this, we get back an ID. So that container's running. Then we're going to run a second one called bit, again, in the same pod recognizer. And then we're going to use this command that I think is really cool in Podman called pod list, and then -- namespace, and then container name. So this is something you really can't see even in Kubernetes, but it really helps you understand what a pod is. So if you look at what containers and pods are, you'll see here, it's showing us that there is bit, this container bit is running, this container Flynn, and then this infra container. This infra container is called a pause. You may have noticed when I listed the images earlier, there was this pause container there, or pause container image. This is just a like kind of a while one loop process that just runs just so that these namespace constructs get created in the kernel. So this is a really beautiful command because you can see we have basically a virtualized network, virtualized C groups, and other namespaces here that we have. And this is essentially what makes a container in Linux. It's the fact that we're virtualizing these different data structures. And then the fact is Flynn and Bit share these data structures, and that's what a pod is. It's two containers sharing these data structures running locally. They basically see the exact same IP addresses and the same host name and all these things. So let's go inspect this pod. This is kind of the internal structure that Podman uses. You wouldn't really use this, but it does have a JSON internal structure where it's tracking how these pods are fired up and run locally. So you can run multiple pods locally. But again, Podman's only on one container host. So let's look at this thing running. You'll see, here we go. You'll see that was the original container that I ran, Tron. And then you can see I have Flynn and Bit running. You'll notice that Podman, like Docker, hides the pause container. You don't really see it unless you look at that one command where I showed you. It showed the infra container running. But you'll see these are actually the three actual commands that are running, or three pieces of programs, I should say, that are running locally in the Linux kernel, essentially the kernel's managing. All right, so now how do we take these two containers that are running in a pod and then recreate this construct in Kubernetes? Well, it's super simple. The beauty here is that we actually just give it the name like we did before, recognizer, except we give it a pod name instead of a container name. And then we give it this -s command or option. This is going to actually go and create the service in Kubernetes, and it's going to generate this YAML. So let's go look at that YAML, similar to how we created for the container. Well, this time you'll see I have a pod definition, and then I have container definitions for both Bit here and Flynn. So you'll see this is a lot more YAML. Or I would really not want to write this myself. And then here we even have a definition for the service. So if you go out here, it has a name for the service. It's got a node port, blah, blah, blah. It generates all this for you with that one command. So now I've got the definition that will help run this in Kubernetes, but I only had to run a single command. So now let's do another new project in Kubernetes to go run this. And then let's go look at that new one. So now we have Tron Legacy out there instead of just Tron. And this is where we're going to go create this more complex, we're going to construct this more complex set of resources out in Kubernetes. And then we're going to watch those get created. Same type of command as we did before. And now we're running. So let's go out and look at this, what happened here. Okay, you'll see it successfully pulled these container images because they are actually both using the exact same container image. But then it went and created Bit. It created the container, and then it did it again for Flynn. And then you'll notice, again, these guys share, they're running in CRI-O, which I didn't mention because OpenShift runs CRI-O as the daemon. This is the container, what people sometimes refer to as a runtime or an engine. This is what actually goes out and does the work on the worker node of firing up the containers. Instead of Podman, it's CRI-O running in OpenShift. And you'll see these containers share security contexts. They share IP addresses. They share, as I mentioned on Podman, you can see they share a namespace, so they actually have access to each other's memory and things like that. And they're running. So now let's go look at this pod. You'll see there's one pod. It's out there running. And then let's look at the service that got created. So you'll see there's a node port type. It's named Recognizer, has an IP address. We could actually go hit this IP in this. If we were running anything of usefulness, we would be able to go hit these ports and basically extract data from this pod. So that was a lot more complex of an example and a lot more useful, right? Like if you're starting to move between Podman and Kubernetes, this is pretty useful. And this may look like it's one way, but actually you can go the other way as well. You can actually export the YAML from Kubernetes, and there's actually a Podman play kube command. So you can actually, something that a lot of people don't realize is you could actually use Kubernetes YAML instead of something like Docker Compose. So you could have two different developers on two different workstations with Podman. One could do a kube generate, the other one could do a kube play, and then they could basically play, a complex set of containers and get those to come up and run locally on their Podman. And then they could actually go out to a Kubernetes OpenShift cluster and run them. So it's very flexible in that you could go from OpenShift to Podman, from Podman to Podman. from developer to developer, or from developer to production, or developer to dev test, essentially. So I wanted to share that because I think that's a really underknown. It's not a well-known feature of Podman, and that's available here. I'm running on RHEL 8.1.1, so it's essentially available today. Now, before I leave you, though, I'm going to show you one more bonus. So Podman generates systemd. So we actually have a lot of the time that want to actually run Kubernetes or OpenShift. I just want to run something very, very simple on a single node. Well, Podman also makes that easy. So literally with a single command, it will actually export the entire service file that you need. You could copy this into, user share, systemd or whatever, or user lib systemd and system, and very easily run this and have this. And you'll notice it actually calls the exact container that you created. So it's smart enough. It will actually start both of those containers. We can do this also with a pod, I should say. We did it here with a container just to show a simple one. But if you were to do the pod, it would actually export multiple files for each of the containers to make sure they run. So we're going to do a quick cleanup. Podman has some cool features where it'll actually kill all the containers. It will remove all the containers. It will kill all the pods, and it will kill all with these -a commands, which are really nice. Then I got to OpenShift, delete the project, delete both of them, and boom, end of demo. So let's jump back to the presentation for just a second. I'm going to stop sharing. All right, you should be able to see my slides. Now, this I left you. This is kind of what we did in the first one, but I want to show you a bonus that you could go do yourself. So if you want to go do this yourself, you could do it like I did it. But I also published a blog, which I have at the end here, that shows you how to do it with Azure Pipelines. So you can actually like pull, again, a trusted image from a trusted place, trusted Red Hat Universal Base Image from a trusted Red Hat Container Catalog, move it into Azure Pipelines, build upon it, publish it to Quay, and then pull it down anywhere you want, whether that's in Podman or in OpenShift. And I show you how to do that in a blog. I don't have enough time to demo it for this session, sadly, but that's a bonus to go do yourself. So I want to just do a quick wrap up. So find, run, build was kind of the first step, right? That's something you can use Podman, Universal Base Image, Red Hat Container Catalog. When you want to share it, you push it out to Quay.io, or you could run your own Red Hat Quay Enterprise server locally if you have security restrictions, things like that. Then if you want to deploy it, Red Hat offers OpenShift is like really our premier platform for running containers. And then if you want to do it locally, you could use something called Code Ready Containers. So if you just Google any one of these things, you'll find them. At the end here, I do have some links to these things. So you should be able to get a copy of this presentation and go out and look at these things, or maybe you could screenshot this. And with that, I'm going to take any questions that you guys have.